heavy wear in the pivot holes on this movement, along with butchered areas next to them. Someone has used a sharp tool to attempt to smash and reshape the brass bearing surface around the pivots. I'll let the viewer decide if this was a high-quality fix to address the issue or not. The worn pivot holes has created a condition where the pinion leaves and gear teeth no longer mesh at the designed depth, causing increased friction. Result is a loss of power transmission between the two. I've installed the bushings needed. Now it's time to focus on the balance. I was going to reshape the balance cone pivots, but they don't run true. The balance staff is bent. It's going to need a new staff made. It'll never keep time like this. To get a visual where the old balance staff is bent, I'll use this precision ground inspection block. Now you can actually see the issue with this balance staff. It's had some rough treatment in the past to get bent like this. Now that it's been disassembled, it's time to fabricate a new balance staff. First, find some staff and pinion steel stock that has been hardened and tempered to a blue color. Old staff measures 223 degrees in diameter. I'll search through these until I find one the same. This is a nice measuring instrument from the early 1800s. Works great, and it's quite accurate. Time to fabricate a balance staff. Looking good. Press the balance wheel onto the staff, roller table. Test the fit up. Looking good so far. It works. Now to adjust the rest of the escapement to the new balance staff. Escape wheel isn't delivering enough power to the balance wheel. It's missing a beat once in a while, and something is dragging. The exit pin isn't going into its complete lock position on each escape tooth. The pin momentarily goes into lock and bounces halfway into the middle of the tooth's locking surface. The guard pin to roller table clearance is erratic. There should be airspace between the pin and the roller table at all times. Not the case here. Guard pin actually contacts and drags on the roller table at times. This all causes friction and slows the balance wheel down. In slow motion, you can see how the guard pin drags on the roller table at times. It's caused by the pallet pins not going into full lock position on the locking surface of the escape wheel teeth. In slow motion, it's easier to see. Pallet pin seems to jump to the center of some of the escape wheel teeth locking surfaces. Locking surface of some of the teeth are worn to a cupped shape. They should be flat. The pins have worn grooves in them. To resurface the face of each tooth to a flat surface, I'll use this fine file. It needs to reach clear down to the circumference of the wheel. This temporary setup will allow a consistent cut to be put on each tooth. Remove material from the root of the tooth only. I'll not even touch the entrance corner of the tooth with the cut. It'll increase the draw slightly, but not much else we can do if we're going to save this wheel. The pallet pins are also badly worn where they slide on the escape wheel teeth, as you can see. I've replaced them with new ones of the same diameter. I've done a final clean. Time to assemble. Oil the movement. All working together good now. Balance staff pivot is running nice and true. Good airspace clearance between the guard pin and the roller table. With new bushings, pinions and gear teeth are now meshing as designed. It's eliminated a lot of friction. Pallet pins are going into total lock now, and the motion has a nice snap to it. This should be a nice timekeeper now. Time to install the dial and the hands. Beveled glass on the bezel. This clock is represented in Ansonia's 1915 to 1916 catalog. It's listed as a novelty clock, number 574.